So welcome to this short video, and in this short video I'm going to have a look at the PIC16F84 integrated circuit. So this is the microcontroller we're using in Embedded Systems 2 in DK740 and in DK843, and I'm just going to give you a quick look at the pins and what each pin does in this very short video. Okay, so we have a PDF file here. This is the first page of the PDF file, and again you can download this file from Moodle if you wish. Here's the table of contents, and we'll be working our way through these various different circuits in different videos. Okay, so let's have a look here at page number 1. First thing I want to do is look at the pinout of the PIC16F84. The first thing to realise it's an 18-pin package. And the version that we're looking at is the PIC16F84, which is electrically erasable. It's the more modern version of the actual integrated circuit. There's an older version of it called a PIC16C84. We no longer use that one in DK740. So it's an 18-pin package and it's electrically erasable. They are the first 2 points about that. Let's have a look at the package itself. Here it is here. There's 9 pins on one side of the integrated circuit, and there's another 9 pins on the other side of the integrated circuit, and this is a dual-in line package. This is an old-fashioned integrated circuit, in other words. Let's look at what each of these pins do. So we've got 18 pins, and I've broken the pins down into different groups. So let's look at the first 2 pins. The first 2 pins are pins 14 and pins 5. Pin 14 is the positive power, that's plus 5 volts. We have to connect plus 5 volts to pin 14. And pin 5 is ground, so we have to connect ground to pin 5. If we don't, the integrated circuit simply will not be powered up and won't work properly. So pins 14 and 5 are power and ground, and you'll always find a power and ground on every digital integrated circuit that you ever look at. Okay, and in this case it's pins 14 and 5. So let's look at the next pins, which are pins 15 and 16. They're the clock input and clock output pins. Every microcontroller needs a clock, a signal that turns on and off very, very rapidly to time the operations that the microcontroller is going to carry out. So we need to have a clock circuit, and we need to connect it to pin 16, that's the clock input. And coming out on pin 15, we'll see a modified version of that clock signal. So pins 16 and 15 are the clock inputs. Let's look at the next line here, which is the master clear or the reset, which is pin 4. Now every microcontroller will have some sort of reset button, and when you press the reset button, the microcontroller will simply reset itself. And in this case it's pin 4. So what I've looked at so far is I've looked at pins 14 and pins 5, which are power and ground, pins 16 and 15, which are clock in and clock out, and pin 4, which is the reset button. So let's now look at the other pins, and they can be grouped into 2 different sections. The first group of pins are called port A pins, and they're called RA0, RA1, RA2, and RA3 and RA4. And they're pins 17, 18, 1, 2, and 3 of the microcontroller. And these are basically going to be used as input lines, or to send logic 1s and logic 0s or digital signals into the PIC microcontroller. So this semester that's what we're going to be doing with all of our port A lines. As well as our port A lines, we've also got port B lines. Now as it happens, we've got 8 port B lines, and they're called RB0, RB1, RB2, RB3, RB4, RB5, RB6 and RB7. And they are pins 6, 7, 8, 9, 10, 11, 12 and 13 of the PIC microcontroller. And these 8 pins are digital output pins. We send logic 1s and 0s out to some other type of circuit connected to port B. So some of these pins, by the way, have other special uses, but we won't talk about that this semester. So RA0, these 2 pins here, RA4 and RB0, they have special purposes. They're dual use pins, but we won't worry about those pins this semester. Right, let's go down to the next page now. Here's a block diagram of a simple PIC microcontroller application. And this block diagram is showing us how all the different pins on the pinout can be used. The first thing we need is power. So pin 14 is going to be connected to 5 volts. You can connect it to any voltage between 2 volts and 6 volts and the PIC microcontroller will still operate. And that's because sometimes batteries lose a little bit of voltage over time. But basically 5 volts is what you need pin 14 connected to. Okay, what about pin 5? Well, pin 5 you were told we have to connect it to ground. So here's pin 5 down here connected to ground. So VSS, pin 5 is connected to ground. I said we needed to have a clock circuit, which has to be connected to pin 416 of the microcontroller. So there it is. So there's the clock circuit connected in there. Now we haven't looked at the details of this clock circuit yet. We'll look at that in the next video. We had a reset circuit, and it's connected to pin 4. And again, we look at the details of this reset circuit in the next video. So pins 16 and 4 are connected to clock and reset. What about port A? Well, port A is normally used as inputs. So what I've shown here is I've shown 5 switches connected to RA0, RA1, RA2, RA3 and RA4. And as we turn these switches on and off, we send logic 0s and logic 1s in on port A into the microcontroller. So that was port A. What about port B? Well, port B is going to be used as outputs, and I've just shown here in this simple application 8 LEDs, 8 output devices connected to RB0, RB1, RB2, RB3, RB4, RB5, RB6 and RB7. So those LEDs can be turned on and off by sending logic 0s and logic 1s to them. So, basically to summarise, the PIC microcontroller needs power, plus 5 volts, ground, a clock circuit, a reset circuit, and then we're going to use ports A and B to connect other devices, simple devices, to this PIC microcontroller. The simplest possible input device you could connect is a switch. The simple possible output device you can connect is a LED. In this particular case, I've got 5 input lines, RA0, RA1, RA2, RA3 and RA4. That's why I've shown 5 switches connected to those 5 lines, and I've got 8 output devices, 8 LEDs out here connected to the 8 port B lines. Okay, thanks for listening, folks. That's a summary of the PIC microcontroller and how you can connect the PIC microcontroller to simple input and output devices.